Welcome to my presentation. This presentation is part of the playlist Indefinite Integrals. In this presentation, we will be solving problems using the rules of integration. Let's look at some examples using the power rule. In this example, let us say if y is equal to integral 3x dx, we want to evaluate this indefinite integral. We can use the power rule to integrate this particular example problem. So since 3 is a constant, we can take that 3 outside of the integration process as shown here, and then write the rest of the example as shown here. 3 times integral x dx. Since we have x there, x dx. So now we are going to use the power rule, and the power rule is stating that when we have x to the power of n, the integral of x to the power of n is going to be equal to x to the power of n plus 1 divided by n plus 1. So since x means x to the power of 1, the exponent is to the power of 1. The ones are implied. So we normally don't write it, but it is implied that it is x to the power of 1. So 3 times x to the power of 1 plus 1, the whole thing divided by 1 plus 1. This is the way the power rule expands when we integrate x dx like that. So 3 times x to the power of 1 plus 1, the whole thing divided by 1 plus 1 plus c. So when we simplify it some more, 3 times x to the power of 1 plus 1 is x to the power of 2, the whole thing divided by 2 plus c, where c is a constant of integration. Whenever we perform the integration process, at the end, there is going to be a constant term which we're going to add to the solution. So 3 times x to the power of 2 divided by 2 plus c is our solution. Let's look at another example. Let's say we have integral square root of x dx this time. We want to evaluate this indefinite integral. So we know that square root of x can be written as x to the power of half. We have a means of converting radical terms to exponent terms. So square root of x is same as x to the power of 1/2 in exponents. So we want to write it in terms of exponents because we can then use the power rule. So since the problem we have is if y is equal to integral square root of x dx, we can rewrite that as integral x to the power of half dx. Now, we're going to use the power rule here and simplify this. This becomes x to the power of 1/2 plus 1, the whole thing divided by 1/2 plus 1 plus c, where c is a constant of integration. So when we simplify the 1/2 plus 1, it converts to 3 over 2, that is x to the power of 3 over 2, the whole thing divided by 3 over 2 plus c. So in the denominator, we have a fraction, 3 over 2. When we bring it over to the side of the expression, it's going to be 2 over 3. It flips over, 2 over 3 times x to the power of 3 over 2 plus c, where c is a constant of integration. So let's look at another example. Let's say we have integral 1 over x cubed dx. We want to evaluate this indefinite integral. So we can write 1 over x cubed as equal to x to the power of -3. When we bring the exponential term to the numerator, the base remains the same, but the exponent becomes a negative value. So it becomes 1 over x cubed becomes x to the power of -3 in the numerator. So now we can use the power rule and simplify this example problem. Using the power rule, we can write the same given example, which is integral 1 over x cubed as integral x to the power of -3 dx. Now when we perform the integration process using the power rule, x to the power of -3 plus 1, the whole thing divided by -3 plus 1 plus c. So when we simplify Simplify this, it's going to be x to the power of -2. -3 plus 1 is -2. The whole thing divided by -3 plus 1 is -2 plus c. Since positive divided by negative is going to be negative, so we have the negative, the answer is is a negative value, negative of 1 divided by 2x squared. What I have done here is x to the power of -2, since it is in the numerator, and since we have a negative value for the exponent, when we bring it to the denominator, it's going to convert to a positive value. So therefore, I'm going to write this one as 1 over 2x squared plus c. As always, when we complete the integration process, we're going to add a constant term c to the solution. So this is how we're going to use the power rule to solve simple example problems. In my next video presentation, we will be solving problems using more rules of integration.